Good afternoon, students. Welcome to the chapter Light Reflection and Refraction. In this class, let us discuss about refraction of light, refractive index, and loss of refraction. So first we shall discuss about the refraction of light. When a light ray enters from a rarer medium to a denser medium, then there is change in direction of propagation of light. There is bending of light. So usually we can tell bending of light. Okay. So that is, this phenomenon is called as refraction. So refraction means when a ray of light enters from the rarer medium to denser medium, that is two different media, then there is change in propagation of light, direction of propagation of light. This phenomena is called refraction of light. So here you can see in the diagram, incident ray is EF, okay, and you can see refracted ray. Next you can see emergent ray, GH emergent ray. Okay, so OO dash is refracted ray. So incident ray, refracted ray, emergent ray. So air is the rarer medium, glass is denser medium. So air means usually we take air as a rarer medium, and denser may be glass, water, kerosene, quartz, turpentine oil, etc. Okay, so denser medium have different refractive indices. So here, when a ray of light enters from one medium to another medium, the light ray bends. Okay, so when ray of light enters from rarer medium to denser medium, it bends towards the normal. We can see in the diagram OO dash bending towards the normal and N dash. Okay, so when the ray of light travels from refractive, when the ray of light travels from denser medium to rarer medium, then it bends away from the normal. Okay, children. So first is you have to keep in mind, when a ray of light travels from rarer to denser medium, it bends towards the normal. When a ray of light travels from denser to rarer medium, it bends away from the normal. You can see in the diagram. So ray GH is bending away from the normal. Okay, M dash. So you can see that one. Okay, so you can see angle of incidence, angle of refraction. Okay, and if you draw incident ray dotted lines, then it will be parallel to the emergent ray. So you should keep in mind. So here we are considering a rectangular glass slab. Okay, so here rectangular glass, so you can see incident ray, refracted ray, and emergent ray. So when a ray of light enters from rarer to denser medium, there is change in speed of light. The change in speed of light, okay, this is called as refraction of light. So the change in speed of light is due to the refractive indexes of different media. Okay, so it depends upon the refractive index of the media. If the refractive index is more, then the speed of light is less. You have to keep in mind, if the refractive index is more, then the speed of light is less. Okay, so that concept you have to keep in mind. You can see here, you can identify here EF as incident ray and OO dash as refracted ray, and GH as a emergent ray. So you can see when the light ray enters from air to glass medium, it is bending towards the normal, and when the ray of light enters from denser to rarer medium, it is bending away from the light, away from the normal. Okay, so when ray of light, so you should keep in mind, when a ray of light enters from rarer to denser, it bends towards the normal. When ray of light enters from denser to rarer, it bends away from the normal. Next we shall discuss about the loss of refraction of light. So loss of refraction of light, they will ask for 1 mark. What do you mean by loss of refraction of light, or define loss of refraction of light? So first line is the incident ray, the refracted ray, and the normal to the interference of two transparent media at the point of interference, at the point of incidence, all lie in the same plane. Second point is the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for given pair of media. And this is also known as Snell's law of refraction. Okay, so Snell's law of refraction is sin A by sin R is equals to a constant. So if they ask for 1 mark straight loss of refraction, then you can write the incident ray, the refracted ray, and the normal to the interference of two transparent media at the point of interference, at the point of incidence, all lie in the same plane. Second point, the ratio of sine of angle of incidence 2, the sign of angle of refraction is constant. That is sin I by sin R is equals to constant. Okay, so this constant value is called refractive index of the second medium with respect to the first medium. Okay, so this constant is called refractive index. Sin I by sin R is equals to a constant. This constant is called a refractive index of the media. Refractive index of the second medium with respect to the first medium. Okay, so these are the two laws of refraction you have to keep in mind. Okay, I think you understood the concept of refraction of light. Refraction of light is nothing but change in speed of light when it travels in two different media. Change in speed of light when it travels into two different media. Okay, so next we shall discuss about the refractive index. The refractive index you can see in the diagram. So this is a glass slab, medium 1 to medium 2. Medium 1 is air and medium 2 is glass. So here refractive index means it is a physical quantity, the relative speed of propagation of light in different media. Okay, so it is nothing but the relative speed of light in two different media. How can we define refractive index? Refractive index is nothing but the ratio of speed of light in medium 1 to the ratio of speed of light in medium 2. Okay, you can see they have given the formula n to 1. We have to write n to 1, that is equals to speed of light in medium 1 divided by speed of light in medium 2, that is equals to v1 by v2. Okay, so here next if you take n12, then we have to write it as speed of light in medium 2 and the speed of light in medium 1 is the ratio of speed of light in medium 2 by medium 1. So n21 means speed of light in medium 1 by speed of light in medium 2. n12 means speed of light in medium 2 divided by speed of light in medium 1. So here the value of refractive index for a given pair of media depends upon the speed of light in two media. Okay, so the value of the refractive index for a given pair of media depends upon the speed of light in two media. Okay, so here the speed of light in air is 3 into 10 to the power of 8 meters per second. Okay, the speed of light in air is 3 into 10 to the power of 8 meters per second. So refractive index is a physical quantity which is relative speed of light of relative speed of propagation of light in different media. So refractive index means relative speed of light in two different media. Okay, so the speed of light in air is 3 to 10 to the power of 8 meters per second. Okay, the value of refractive index for a given pair of media depends upon the speed of light in two different media. So refractive index, if the refractive index is more, then the speed of light is less. If the refractive index is less, then the speed of light is more. That you have to keep in mind. Okay, then afterwards, so you can see in the diagram, medium 1 is air, medium 2 is glass. So n21 is speed of light in medium 1 by speed of light in medium 2, that is v1 by v2, and n12 is speed of light in medium 2 by speed of light in medium 1, v2 by v1. So refractive index is represented by the symbol n. Okay, sometimes they are represented by mu or neta. Okay, so here in textbook they are represented by n, so that you have to keep in mind. Okay, so what is absolute refractive index? It is the ratio of speed of light in air to speed of light in medium. So if the medium 1 is air, then we can call it as a absolute refractive index. Okay, so absolute refractive index of a medium is simply called as refractive index. Okay, so if the medium 1 is air and medium 2 is other than air, then ratio of speed of light in air to speed of light in medium is absolute refractive index. Okay, so you may here they may ask neta w, what do you mean by neta w equals or nw equals 1.33 means the ratio of speed of light in air to the speed of light in water is equals to 1.33. That is the meaning you have to keep in mind. What do you mean by, they may ask a question for 1 mark, what do you mean by the term nw equals 1.33? Then you have to write, it means that the ratio of speed of light in air and the speed of light in water is equals to 1.33. Like that you have to write. Okay, so I told you what do you mean by absolute refractive index. If the medium 1 is vacuum and medium 1 is vacuum, and medium 2 is other than air, then we call it as the absolute refractive index. Okay, so again I will tell you clearly what do you mean by absolute refractive index. If the medium 1 is vacuum or air, then the refractive index of the medium 2 is considered with respect to vacuum. This is called absolute refractive index. So absolute refractive index. So what is refractive index? It is the ratio of the speed of light in medium 1 to speed of light in medium 2. What is absolute refractive index? If the medium 1 is air, then we call it as a absolute refractive index. Then afterwards they may ask, what do you mean by the term NW equals 1.33? That means the speed of light in air to speed of light in water is equals to 1.33. And here you can see in tabular column, okay, so they have given absolute refractive index of materials, of media, they have given material, medium and refractive index. So for air it is taken as 1.003, for diamond it is highest 2.42, for diamond it is highest. Okay, so there is no need of keeping in memory this tabular column, just for reference they are given. Okay, so here just for reference they are given. So air it is having refractive index 1, for diamond it is having refractive index 2.42, for water refractive index is 1.33. You can just go through, that's all. Okay, so this is about the refraction of light, laws of refraction and refractive index. Okay children, I hope you have understood about refraction of light. Okay, so go through the textbook, page number 83, 84 and 85. Okay, so any doubts you ask me in the class. Thank you.